Welcome to my class. In today's class, we will solve a few problem sums based on addition and subtraction of algebraic expressions. These are 4 problem sums that we will solve in next few couple of minutes. So let's get started. The first problem says that we have to add this algebraic expression with this second algebraic expression and then with this third algebraic expression. Now what we can see here that in these 3 algebraic expressions, we have 3 variables a, b and c along with their constant coefficients and sign. So first what we will do, first we will combine all these terms as per their variable. So what we can see here that we have separated all the a and we have grouped or combined them together, and then we have grouped all the b along with their coefficients and sign, and then similarly we have grouped all the c here along with their coefficients and sign. So next what we will do, we will simplify their coefficients. As in the first group a is common, a is the common variable, so that we have taken here as a common factor, and then all the coefficients we have grouped together, and that same thing we have done for b as well as c. So what we can see here that within every bracket we have 3 rational numbers which we have to add along with their sign. As these rational numbers are given in fractions, so for every addition of these fractions or rational numbers, what we will do is we will take the LCM of the denominator and then next we will proceed accordingly. So we have taken the LCM of the denominator and we have proceeded accordingly with the numerators. And after simplification, we will be getting from this addition result, we will be getting 23 by 6a. Then from this result of addition, we will be getting minus 14 plus 10 minus 4 minus 4 minus 5 minus 9. So it will be minus 9 by 4. Then the variable is b. And then from this result of addition, we will be getting 70 plus 8, 78 minus 25 is, it will be 53. So 53 by 20 C. So the final simplified answer will be 23 by 6 A minus 9 by 4 B plus 53 by 20 C. Next we will simplify again this addition of the algebraic expressions. Here the first algebraic expression will be added with the second and then with the third algebraic expression. So what we can see here in all these terms and all these algebraic expressions that we have one variable which is x and we have different powers of x. Like here we can see here the power of x of that variable is 1, here the power is 2, here the power is 3. In the first expression we don't have x, we don't have the power 1 of that variable, but we have 2 and 3, and along with those two terms we have constant term as well. And in the second algebraic expression also we have some constant term, and in the third expression we have the power 2 of that variable x square, and then we have simple x, and along with those two terms we have here a constant term as well. So in these 3 algebraic expressions, what we can see here that we have 3 different powers or forms of that variable x square, x cube, and along with those 3 terms we have constant as well. So what we will do in the next step is we will group or combine all these terms as per the power of x. So what we can see here, we have grouped as per the power of x and we have arranged in descending order of the power. So the first term or variable here is x cube, then we have x square, then we have x, and then we have all the constant coefficients. Now in case of powers and exponents, we have seen there that for any base, if the power is 0, then that value is always 1. So here also we can think that here we are multiplying this result of addition by 1, and in place of 1 we can think of as if we have x to the power 0. So x to the power 1, and then the next variable is x to the power 0. we may not think that way also. What we will do, we will just combine all the constant terms in that simplification. So next what we will do, we will simplify all these additions of fractions. So what we did in the previous example, likewise we will take the LCM of the denominator and then we will proceed with the numerators accordingly. Now after simplification, what we will get is 7 plus 3, 10 by 2, so it will be 5, then x cube. Here it will be 13 minus 2, so it will be 11, 11 divided by 4, and with that we have x square. Then we have minus 2 minus 5, so minus 7 divided by 2. In the denominator we have 2, then x, and then here it is 5 plus 1 6, then minus 6 0. So finally in the final result or in the final algebraic expression, we will not have any constant term. So this will be our final answer of the simplified answer of this addition of algebraic expressions. Next we have subtraction. So we will subtract this algebraic equation from this algebraic equation, and we can see here we have x, y, two variables and their different powers. Now in these two algebraic expressions, first we have to identify that what are the different variables we have. Here we have one variable xy, then we have another variable where we have two separate variables x and y, and here the power of x is 1, power of y is 2. So this combined variable will be xy square. Then the next form that we have is x square y, where the power of x is 2, the power of y is 1. So the third variable or third format that we have is x square y. Now in the second algebraic expression, we also have x square y that we have already considered. Then we have xy square that we also have considered, and xy. That means in these two algebraic expressions we have these three formats, and according to this format of the variables we will group or combine the terms. Now here what we have done, 2/3 x square y first we have written, and then where we have another x square y term whose coefficient is 1, and since we are subtracting, so here we have minus sign. So finally we have taken that term as negative, so here we have written minus x square y. Then we have xy square term in the first algebraic expression, and along with that we have coefficient 3 by 2 that we have written here. Then we have xy square term in the second expression also, and that coefficient is minus 4 by 5, and we are already subtracting, so we have already here the minus sign. So minus minus it will be plus, so plus 4 by 5 xy square. Then in the first expression we have minus 1 by 3, minus 1/3, and then in the second expression we have plus 4 by 3 xy, so plus, and here we have one minus sign, so it will be minus 4 by 3 xy. Next what we will do, we will, since these terms are common, x square y, xy square and xy, so we will simplify their coefficients and we will take those terms as a common factor outside. After doing that, it will look like this. Next what we will do, as we did for previous two examples, we will take the LCM of the denominator and we will proceed with the numerators accordingly. So here it will be 3, the LCM, and it will be 2 minus 3, then we have the term x square y. Then here the LCM will be 10, so 10 divided by 2, quotient will be 5, 5 multiplied by 3, it will be 15. Then 10 divided by 5, quotient will be 2, 2 multiplied by 4, it will be 8, and we have term xy square. Next the LCM will be 3 only, and here it will be simply minus 1 minus 4, and then we have the term xy. So finally after simplification it will be minus 1 by 3 x square y. Then the next term will be 15 plus 8, it will be 23 by 10 xy square, and then we have minus 5 by 3 xy. So this will be our simplified answer for this subtraction of algebraic expressions. Now the next problem sum is again related to subtraction of algebraic expressions, and here we have to subtract this expression from this, and what we can see here, we have three variables x, y, z, and their different powers. So accordingly we will separate or we will group those terms. So in the first algebraic expression we have x square yz term, and in the second expression also we have the similar type of term x square yz, so we have grouped them together. And then we have in the first expression x square y term, and the coefficient is 2 by 3, and in the second expression also we have x square y term, coefficient is 3 by 2, and since we are subtracting, so we have considered that negative sign. So here it will be, we have taken this term as a negative term, so minus 3 by 2 x square y. And then in the first expression we have xyz term, minus 3 by 2 is the coefficient, and in the second expression we don't have any such terms, so we have only one such term. And in the second expression we have y, whose coefficient is 4 by 5, and in the first expression we don't have any such term whose variable is only y. And here we are subtracting, so we have considered the negative sign, so it is minus 4 by 5 y. Next, what we will do, as we have done for the other problems, we will simplify the coefficients. For that we will perform the LCM of the denominator, and accordingly we will proceed with the numerators. So after grouping or combining this, the whole expression will like this. Now we will take the LCM of 5 and 3, which is 15. So it will be 15 divided by 5, quotient is 3, so it will be 36, plus it will be 5, so 5 multiplied by 1, it will be 5 only. Then for the second term, the LCM will be 6 divided by 3, quotient will be 2, so it will be 4, minus it will be 9, and then here we have x square y. Then we have minus 3 by 5 xyz minus 4 by 5y, and after further simplification it will be 41 divided by 15 x square yz, minus it will be minus 5 by 6 x square y minus 3 by 5 xyz minus 4 by 5y. So this will be the final or simplified answer of this subtraction of algebraic expressions. So we have solved all these 4 problem sums. In the next class we will be solving a few more problem sums based on addition and subtraction. With this I end today's class. Thank you.